let's talk about the physical geography for this region. We've got all sorts of cool stuff to talk about here, especially about the way that the physical geography has impacted the cultural geography and patterns of this region. So, what we have here in this region with South Asia is this big chunk of land. Sometimes it's called a subcontinent, but since it has run into the continent of Asia, it's a large peninsula. Okay, so just like we saw in Europe, where we had a peninsula that was a piece of Eurasia, that is exactly what we have here. And this is a really beautiful peninsula. Okay? You got the water on three sides there. There's the Arabian Sea, there's the Bay of Bengal over here on the east, and we have this large cone creating the peninsula there. This is a pretty big region. We could fit 8 Texases in this region. And this placement of Texas here, in the shape of it, over this region, is at the correct latitude. Okay, so it's at the same scale and the correct latitude. So we would fit about 8 Texases in this region. Here's the Tropic of Cancer. The equator is further south. But if this is the latitude of Texas, and we know what South Texas is like, especially in the summertime, around Houston, around the Gulf, we now know how sticky and hot it can be. It should tell you something about the climate and the weather in this area, because almost the entire region is south of South Texas. And there is, of course, some variation here because we have some different shape to the land. We have a whole bunch of mountains here that are not there in Texas. But just talking about latitude, the position on the planet, and therefore the amount of insolation that this area gets, most of this region is south of where Texas is. Okay, so that'll give you a reference point. So most of this region is closer to the equator, hotter than South Texas. Okay. Geologically, as I said a second ago, or alluded to, South Asia is actually a separate plate. It is a separate tectonic plate that has run into the Eurasian continent. Okay? It has been moving northward at about 2 inches a year for a very, very long time. And while that may not seem like 2 inches a year is very fast, in geologic time, that's actually basically speed racer. Okay? So it's been moving north quite quickly, and that has been creating some impacts. What is the result of the fact that we have a plate moving to the north and running into another plate? Well, there's a couple results. First, there's earthquakes. Okay? We've got tectonic plates hitting each other, coming together, right? Slipping, sliding, that kind of thing. Earthquakes. But we also have crumpling of the crust. And that is how we get all of these mountains here in the northern part of this region. The Himalayas are created through plate tectonic movement, through the crumpling of the crust as the Eurasian continent gets pushed and crumpled as South Asia, as the Indian plate hits that continent. Okay, so that is actually how we get the Himalayas. And remember the Tibetan Plateau, that whole area being uplifted, that too is because of that plate running into Eurasia and lifting the whole thing up. As it lifts, it crumples, and we get both the Tibetan Plateau and all of the Himalayas. And you can see it on this map here. We've got an entire zone where this impact is creating chains and chains of mountains. Okay? These are tall mountains. The average is more than 4 miles high, which is very significant. In fact, the highest peaks in the Himalayas are almost twice as high as the tallest mountains that are in Colorado and in California, which is where the highest peaks in the continental US are. So we've got some really high mountains here. And in fact, this is, of course, why this area is often called the roof of the world, because it is the highest elevations that we have. And there's just a silly diagram. This is from XKCD, who does some really great cartoons. We'll actually see one when we get to Oceania. But this is how the Himalayas were formed. Right? We've got 2 very ancient continents. A piece broke off, and this piece, the Indian subcontinent, has been moving north, hitting Eurasia, and making the Himalayas. Okay, so here's what they look like then. Right? This is the mountains. This is what is the result of that tectonic activity. And there have been a large number of earthquakes over the years. This is quite a tectonically active area. But aren't these beautiful? And that's just so striking. This mountain right here, this highest peak, that of course is the highest elevation in the world. That is Mount Everest. So it's the world's tallest mountain in terms of elevation, distance above sea level. It is more than 29,000 feet above sea level, and it is a breathtaking sight. It's quite often shrouded in clouds, but it is located right here on the border between Nepal and Tibet, which is, of course, controlled by China at this time. So it's right there. You can actually approach it, you can climb it from either side. Most people are tending to approach it from the Nepalese side. There are a lot of people who are very interested in climbing Mount Everest. The first man who did it, Sir Edmund Hillary, was actually from New Zealand, but he was accompanied by a man who was a Sherpa. And the Sherpa are one of the local people. There's a number of indigenous groups that are in this area. The Sherpas are one of them. And these mountains are sacred sites. They are seen as deities by the indigenous people. Remember, of course, that since it's an indigenous religion, it is an ethnic religion and tied to physical places. And the fact that a large number of people are coming and climbing this area is increasingly concerning the Sherpas. Because while they have been employed for a very long time, being the stewards and being the guides up the mountains, they're expert mountaineers. They live in this environment, not, of course, high on the slopes on Everest and some of the other higher ones, but high in these mountain valleys. And so they're experts at this. And they are increasingly concerned because there are more and more inexperienced people who are attempting it, people who don't have enough experience climbing, and there's more and more trash and environmental damage being left on the mountains. And so a couple years ago, there was actually a couple groups got into a bit of a fight, and they kind of crowded up in a very dangerous area. There was an avalanche, and a number of people died. And the Sherpas actually saw this as an indication that the mountain is getting increasingly angry, and they are less and less interested in taking big groups of people up the mountain. And so the Nepalese government, the government of Nepal, is very concerned about this and is working with the Sherpas to find solutions, because Nepal very much depends on the money that comes from the tourists, that comes from the people who want to climb, because it takes a lot of money to do this. The average cost of an attempt on Everest, and it is just an attempt, that doesn't mean you're going to get up, because it's still an incredibly dangerous thing and storms can blow in very quickly. The average cost of an attempt is about $60,000, because you need a plane to get there, right? And then you can't just get there one day and climb it the next. It takes quite a while to do, and you have to acclimate to this high elevation. So you actually go up in stages. There are camps up the side. And so it's a large undertaking, takes a lot of equipment, takes a lot of training. And so the Nepalese government is very invested in making sure that the climbing continues. But we do have that conflict, that controversy that we've talked about with tourism brings money, it brings jobs for the Sherpa, but at the same time, there's an environmental cost and there's a cultural cost. And so we have that issue. Okay. Here's another shot of the Himalayas. Isn't that just amazing? Look at that, just the folding, and you can just see the successive waves of the bending of the crust. And here is another shot. You can see that just uplift here, that shelf of mountains. And then, of course, this is the Tibetan Plateau. So these mountains are definitely high enough to block the air, as the air flows here from the south, which it does for part of the year, and therefore to affect the climate and the weather, but especially the climate. Okay. And they are enough to trigger the famous Indian monsoon. And we will talk about that monsoon and what that means in the next lecture.